next here a factor theorem. Okay, so one more time. So remainder theorem, it tells us how to find remainder when we divide our polynomial p of x by x minus c. Okay, if our divisor is in the form of x minus c, and if we are using this x minus c to divide our polynomial p of x, then the remainder is p of c. It means to find the remainder, you replace every x of a polynomial function by that c. Now the next we have the factor theorem. Okay, now if now here x minus c is a factor of a polynomial p of x if p of c is equals to 0. So here what it means, for example, let's say we have p of -2 equals to 0. Okay, so we have a p as a some polynomial. Okay, and if you have your -2 as an input, okay, if you replace your every x of a polynomial by -2, and if you end up getting p of -2 equals to 0, then x minus this, so this is our c. Okay, so x minus c, so x minus -2, which is x plus 2, will be a factor for this polynomial p of x. Okay, in the similar way, for example, if you have p of 4 equals to 0, then the factor for this polynomial is x minus this number 4. So x minus 4 is a factor for a polynomial. Okay, so here we have example here. So we have to determine whether x plus 3 is a factor of this polynomial or not. So our polynomial p of x is 2x cubed plus 3x minus 2. So this is our polynomial. Okay, now to be a factor, so we want to know whether x plus 3 is a factor for this or not. Okay, if x plus 3 is a factor of this polynomial, and if you divide this polynomial by its factor, we get the remainder equals to 0, right? So here this is our divisor, so let's divide this polynomial by x plus 3, and if the remainder is equals to 0, then x plus 3 is a factor. Now you can use a long division, you can use a synthetic division, or you can use a remainder theorem. Okay, so our divisor is x plus 3. Okay, so our divisor d of x is x plus 3, and this x plus 3 is in this form, is in x minus c form. If we compare this, what do we get for c? What should be our c equals to? So for x we have x, right? Now now we can rewrite x plus 3 as a x negative 3. Okay, so these two are same thing. So for x we have x, for negative we have negative, and for c we have -3. So our c is -3. We want to know whether when we divide p of x by d of x, our remainder is 0 or not. So our target is finding remainder. So let's find remainder, and to find that we are using remainder theorem. Okay, we know c is -3. Our remainder is p of this number. So p of c is the remainder. So in our case, c is -3. And to find p of -3, you replace every x of that polynomial by -3. Okay, so this is 2 times -3 cubed plus 3 times -3 minus 2. Okay, so this is our remainder theorem. So we have 2 times -3 cubed is -27, 3 times -3, -9, -2. So 2 times -27 is -54 minus 9 minus 2, and this is -54, -9, -63, -2, -65. And this number is not equals to 0. Okay, so it means x plus 3 is not a factor. Okay, so to be a factor, the remainder has to be equals to 0. So x plus 3 is not factor of polynomial p of x. Okay, so if you are asked to, so this is the method you can use only when your divisor is in the x minus c form. Okay, so if you have a different divisor, then you have to use a long division or a synthetic division, okay, to check whether the given divisor is a factor or not. And we do have a very similar example on our review handout, like number 4 and number 3. Okay, so this is one way. Or if you want to use long division, so let's use long division. Okay, so let's divide this polynomial. So we have polynomial 2x cubed plus 3x minus 2, and let's divide by x plus 3. Our target is finding the remainder, and if the remainder is 0, then x plus 3 is a factor. And how do we do a long division? So what is the first step of long division? We take the first term of this polynomial, right, 2x cubed, and we divide this 2x cubed by the first term of the divisor. So what is 2x cubed divided by x? It is 2x squared. Now in the next step, we multiply this 2x squared and every term of the divisor. So 2x squared times x is 2x cubed. 2x squared times positive 3 is positive 6x squared. Now what is the next step? We flip the sign. Okay, 2x cubed is positive, we make it negative. 6x squared is positive, we make it negative. So negative 2x cubed, positive 2x cubed, it is 0. Okay, now the next, positive 3x and negative 6x squared. These are not like terms, so let's write them as it is. So we have negative 6x squared as it is, and drop the remaining positive 3x and negative 2. Now the next is the same step. So you take the first term. So you take negative 6x squared and divide by x. So what is negative 6x squared divided by x? How much we get? We get negative 6x. Now you multiply negative 6x and every term of divisor. Negative 6x times x is negative 6x squared. Negative 6x times positive 3 is negative 18x. Do not forget to flip sign. Negative 6x squared is negative, we make it positive. 18x is negative, we make it positive. So positive 6x squared, negative 6x squared, 0. Then the next positive 3x plus 18x, that is 21x. And let's drop negative 2. Now we repeat the same process. You take the first term, 21x, and divide by x. 21x divided by x is positive 21, right? Now we multiply each term of divisor and this positive 21. So positive 21 times x, that is positive 21x. Positive 21 plus 3, that is positive 63. Do not forget to flip sign. So 21x is positive, let's make it negative. 63 is positive, let's make it negative. Okay, so negative 21x, positive 21x, 0. And negative 2, negative 63 is negative 65. And this is our remainder r of x. Okay, this is our quotient q of x. So when we divide our polynomial by x plus 3, our remainder is not a 0. It means this divisor is not a factor for this polynomial. Yes?
What did you multiply 3x by to get minus 18x?
18x. Okay, so here negative 6x times positive 3 is negative 18x. Okay, so you are, once you have the quotient, you have to multiply each term here. So negative 6x times x, negative 6x squared, negative 6x times positive 3, negative 8x. But to find negative 6x, you are taking first term and dividing by the first term. Okay, so this is another method, or if you feel comfortable with synthetic division, you can also use synthetic division. Okay, any question up to here? So if the remainder is not 0, then the divisor is not a factor. Okay, now let's go to the next here. So here we will be finding the real 0 of a polynomial. Okay, so we have to show that x equals to 4 is a 0 of this polynomial, and use this fact to completely factor p of x. Now we have the polynomial 3x cube negative 4x square negative 48x plus 64, and it's asking us to factorize. Okay, and we want to know whether x equals to 4 is a 0 for this polynomial or not. Now what does it mean by x 0 of a polynomial function? So finding a 0 means finding the x-intercept. Okay, do not get confused. So if you are asked to find the 0 of a function, means you are finding a x-intercept for that function. Now how do we check whether x equals to 4 is a x-intercept for this function or not? So if 4 is a x-intercept, what would be the value of y? The output has to be 0, right? So every point on the x-intercept has a y coordinate. Output is 0. So if 4 is a x0 of this function, when you replace every x of this function by 4, if your output is 0, then x equals to 4 is a 0 for this function. Okay, so to check whether x equals to 4 is a 0 for this function or not, we find p of 4. So we find p of 4. So to find p of 4, let's replace every x of a function by 4. Okay, so that is 3 times 4 cube negative 4 times 4 square negative 48 times 4 plus 64, and this is 3 times 4 cube. Okay, that's a 16 times 4 is what is 16 times 4? That's a 64. Okay, then 4 cube, this is 4 times 4 square, that is 64, minus 48 times 4 times 8, that's 32. 4 times 4 16 plus 3, that is 19 plus 64. Okay, now 3 times 64, that's 18 and 19. Okay, this negative 64 positive 64 is gone, we have negative, and this is 0. Okay, so p of 4 is equals to 0. Okay, so when your input is 4, our output is 0. It means 4 is the x-intercept. 4 is the real 0 for this polynomial function. Okay, since our p of 4 is equals to 0, okay, since p of 4 is equals to 0, x equals to 4 is a 0 of p of x. It means x equals to 4 is a x-intercept for this function. Also, x equals to 4 is one solution for that polynomial function. Okay, now if our p of 4 is equals to 0, now can we find a factor for this polynomial function? So what it tells, what our factor theorem tells. So if p of, okay, so according to our factor theorem, if p of c is any number, is equals to 0, then x minus c is a factor of function p. Okay, this is our factor theorem. Okay, now here p of 4 is equals to 0. Now what is one factor for this polynomial? So if p of 4 is equals to 0, then what is the factor according to factor theorem? X minus our c is 4, so x minus 4 is a factor. So x minus 4 is of fact is one factor, okay, factor of p of x. We have to factorize this polynomial completely, okay, so this is not the only one factor, we have to find the remaining factor. Now how do we find the remaining factor? Now this is a cube, okay, so the degree is 3, so we can't use AC method, FOIL method, okay. So here now since the remainder is 0, bless you, so in the very section 3.3, what do we know? We have a polynomial p of x, and if we divide polynomial by our divisor d of x, then we can rewrite our p of x as a quotient time the divisor d of x, okay, and the remainder is 0 here. Now are these two in a factor form? So in between q of x and d of x, there is a product sign. So these are in a factor form, right? So here we will divide this polynomial by x minus 4 and find the quotient here. And that quotient will also be a factor because our remainder is a 0. Okay, so if the remainder is 0, then the divisor and the quotient will be a factor. So let's divide this polynomial by x minus 4. Now what method do you want to use? Do you want to use a long division or a synthetic division? We use a long division, so let's do a synthetic, okay? You can use a long division, it doesn't matter. Now it will be a review for a synthetic division, but it's okay if you use a long division. So let's divide our polynomial. So let me write down that polynomial p of x one more time, which is 3x cubed negative 4x squared negative 48x plus 64, and we are dividing by our factor x minus 4. So this is our divisor, x minus 4. Okay, now to use synthetic division, your divisor x minus 4 must be in x minus c form. Now both of them are in a same form. So what will be our c in this case? C is 4. Okay, now for a synthetic division, what is our next step? We write down the coefficient of each term. Okay, so we collect coefficient of each term. So the coefficient of cube term is 3, coefficient of square term is negative 4, coefficient of x is negative 48, and a constant is 64. We are dividing this by c, which is 4. You drop the first coefficient as it is. Now multiply with the value of c. So 3 times 4 is 12. Write down below next coefficient. Do not flip sign for synthetic division. Now negative 4 plus 12 is positive 8. Now repeat the process. 8 times 4 is 32. Write down here. Negative 48 plus 32, that is negative 16. Now multiply negative 16 and 4. That is negative 64. We have 0. What is this 0 for us? This is the remainder r of x. Now we need to write down the quotient. To write down the quotient, we need to know the degree of a polynomial. What is the degree of a polynomial? 3. So if the degree of polynomial is 3, our quotient will have a degree less by 1. So this quotient will have a degree 2. It means the first term has to be x squared. Okay, so this 3 is the coefficient of x squared, 8 is the coefficient of x, and negative 16 is a constant. So 3x squared, 8x, that's a positive 8x, negative 16. So this is the quotient. Okay, now let's write down our p of x as a divisor d of x times quotient q of x plus remainder r of x. We know r of x is 0. So our divisor is x minus 4. Quotient is 3x squared plus 8x minus 16. Now we have a c. We had one factor. Now we found second factor. Okay, which is the quotient. Now the second factor is in quadratic form. So we have to factorize completely. Now what method do we use to factorize this trinomial? So this is a quadratic form. The coefficient of square term is not 1, so we use a AC method, right? So let's factorize. This is our A, this is our C. So A times C. So 3 times 16 is, that's 8, 48. The next step, we write down every pair of factor of 48. So what are the pair of factor of 48? 1 and 48 is one factor, one pair. 2 times 24, that's the next. 3 times 16, 4 times 12, 6 times 8. So these are the pair of factor of 48. Now we choose one pair of factor to rewrite our positive 8x. Now which one do we pick here? So we can add this pair of factors or subtract this pair of factors to rewrite positive 8x. Which would be the best pair? 4 and 12, right? So what do we have to do? Is it 4 plus 4 minus 12 or 12 minus 4? Yes, because 8x is positive, okay? So we have 3x squared as it is. Now we will rewrite positive 8x using this number. So that is positive 12x, negative 4x, and we have negative 16 as it is. Now we make a pair of first two term, pair of last two term, factorize. So we have 3x as a common factor. We have x plus 4. Negative 4 is a common factor, x plus 4. Now here x plus 4 is common. So let's factor out x plus 4. And we have 3x minus 4 as it is. Okay, so our p of x looks like, so p of x is, we have x minus 4, which we already have here. Okay, then we have x plus 4, and the next 3x minus 4. Okay, now, and these are the factors for this polynomial. Okay, so we can use synthetic division or a long division to find a factor for this polynomial. Now from here, can you find the remaining real zeros? So we already have one real zero as a 4, right? Minus, okay, now it's easy. Okay, once you have your polynomial in a factor form, finding real zero is really easy. Okay, so you take each factor and find a number that make each factor 0. Okay, if you take this factor, for what x value this factor is 0? For 4, right? Now you take the second factor, for what x value this factor is 0? Negative 4. Now we have one more factor. Now for what x value this factor is 0? 4 over 3. 4 over 3. Okay, if this is something you feel difficult, then you just write down that factor x minus 4, set it equals to 0, and you solve this for x. Okay, then you get that real 0. So 4 over 3 is the real 0. So these are the three real zeros for this polynomial function, or these are the x-intercept, or these are also the solution for this p of x equals to 0. Okay, any question up to here? And this is the next type of question you will see on your next exam. Okay, you will be given a polynomial and you have to factorize that polynomial completely, okay, and find the real zeros. Okay, any question? Okay, now let's go to the next. Okay, so here we have a p of x, which is the polynomial function. C is a real number. Okay. Now the next, if that is the case, so p of c is equals to 0. So we have a polynomial p of x and c is a real number, okay, and all these statements are exactly same, okay. So if p of c is equals to 0, then x minus c is a factor, and this is according to factor theorem, okay, and c of 0 is a x-intercept for a graph of that polynomial function. So here let me go back to our example. So here p of 4 is 0, right? So this is what we know. So we know p of 4 is 0. If this is the case, means x minus c is a factor. So our c is 4. So x minus 4 is a factor, and that's what we had here. And next 4 0 is also a x-intercept, okay. So it's the same thing. So p of 4 equals to 0, or saying x minus 4 is a factor, or p of 4 is x-intercept. So all these statements are equivalent, okay. So if the remainder is 0, then we can find the factor, we can find the x-intercept. So here we have the table to complete. Okay, so we have a polynomial p of x, and we know the x-intercept for that polynomial function. Now can you tell me what is the 0 for that polynomial function p of x? It's 5, okay. So 5 is the 0. Now can you tell me the factor, one factor for that polynomial function? X minus 5. X minus 5 is a factor, okay. Now for the polynomial h of x, we know the factor x minus 3 is a factor. Now can you tell me what will be the 1 0 for that h of x? 3, okay. So this is 3. And what will be a x-intercept? 3 0. Next we have a g of x as a polynomial. We know negative 1 is a 0 for this g of x. Now what will be x-intercept? Negative 1 0. And what will be a factor? X minus this number. So which is x plus 1 is a factor, okay. Once we know x-intercept or a factor or a 0, we can find the remaining, okay. If you are given a 0, you can find x-intercept, factor. If you are given a factor, you can find 0 x-intercept. Okay, any question? Okay, now let's go to the next one. So next here, the number of real zeros for a polynomial, okay. So we have a polynomial function p of x with a degree n, okay, and it has a at most n number of real zeros, okay, and each real zero has its multiplicity as well, okay. That's what we did in our previous section, okay. The next there is the rational zero, okay. Now so our rational zero, we use p over q for the rational zero, okay. P over q is a rational zero, and here p is, so we have a, okay, just let me rewrite that. So we have a rational zero, and this rational zero is p over q. Now what is p? P is a factor of a naught, and a naught is a constant, okay. This is a constant term on that polynomial. Factor of constant divided by q. Q is a factor of an, and this an is the coefficient of leading term. Coefficient of leading term. Now we have a rational zero, And this rational 0, it helps us to identify the real 0. Okay, our target is finding a real 0 for a function. Our target is finding the x-intercept. Okay, our target is factorizing the polynomial. Okay, for that we need a rational 0. Okay, we define a rational 0. Our rational 0 is p over q. So how do we find the p? P is the every factor of a constant term on that polynomial. Okay, q is the factor of coefficient of leading term. Okay, and we take p and q to find our rational 0. So let's go ahead and take an example here. Okay, so here we have this polynomial. Now if you are asked to find a real 0 for this polynomial, how would you find? Is it easy? So finding real 0 means you are finding a number that make our output or that make this expression equals to 0. So for what x value this expression is equals to 0? So it's not easy. Okay, so here rational 0, it helps us to find those real zeros. Okay, so let's go ahead and find rational 0. So our rational 0 is p over q. Now what is p? P is a factor of constant. Now in this polynomial, so which term is a constant term? So which one is constant? 2. Now what are the factors of 2? You have to write down every factors of 2, including positive number, negative number. So what are the factors of 2? Factors of 2 means you tell me a number, every number that divides 2. So what are the numbers that divide 2? 2, 1. Do we have any more? Negative 2, right? Negative 1. So factors of constant is negative 1, positive 1, negative 2, positive 2. So these are the numbers that divide 2. Divided by q. Our q is the factor of coefficient of leading term. Now what is the coefficient of leading term here? 3. And what are the factors of 3? You have to write down every number that divide positive 3. So which is negative 1, positive 1, negative 3, positive 3. Okay, so these are the, so here we have 4 options for p, we have 4 options for q. Now let's find p of q. Now you take each number, so one by one. Okay, so let's take p equals to negative 1 and q equals to negative 1. So what will be p over q? 1, right? So negative 1 divided by negative 1 is 1. So 1 is 1 rational 0. We have more here. Okay, next, so let's take negative 1 as a p and let's take 1 as a q. So negative 1 divided by 1 is negative 1. Let's take negative 1 as a p and let's change q, which is negative 3. So negative 1 divided by negative 3 is positive 1 over 3. We still have one more. So negative 1 divided by this positive 3 is negative 1 over 3. So we are done with negative 1. Now let's take positive 1. Okay, so let's take this positive 1 in the numerator. So positive 1 divided by negative 1 is negative 1, which we already have it. So let's not repeat. So positive 1 divided by positive 1 is positive 1, which we already have here. So positive 1 divided by negative 3 is negative 1 over 3. It's already here. Positive 1 divided by positive 3 is positive 1 over 3. It's already here. Now let's go to negative 2. So negative 2 divided by negative 1 is positive 2. Negative 2 divided by positive 1 is negative 2. Negative 2 divided by negative 3 is positive 2 over 3. Negative 2 divided by positive 3 is negative 2 over 3. Now the next is, let's take positive 2. So positive 2 divided by negative 1 is negative 2. It's already here. Positive 2 divided by positive 1 is positive 2. It's already here. Positive 2 divided by negative 3 is negative 2 over 3. It's already here. Positive 2 divided by positive 3 is positive 2 over 3. It's already here. So these are the rational zeros for this polynomial function. Okay. So you have to find P, you have to find Q. P is every factor of a constant. Q is every factor of coefficient of leading term. Okay, so here we have a 4 option for P, you have a 4 option for Q. So you have to make every possible combination. Okay, so the easiest way here is that you take one value of P and take each value of Q one by one and find what is P over Q. Or you can just take one value of Q and take every value of P one by one, and that would be your P over Q. Okay, so these are the rational zeros. These are not a real zero. Okay, you have to be able to find the difference here. Okay, so these are the rational zeros. Now to find a real zero, so we have this option. So out of this number, there is at least one real zero. Okay, so we have this option here. These are the rational zeros. Now out of this number, there is at least one real zeros. Now it's going to be a hit and trial. Okay, we take each of these real rational zero, we replace every x by these rational zeros, and if the output is equals to 0, then that number is a real zero. So let's start with positive 1. You replace every x by positive 1. So this is 3 times 1 cube. So 3 minus 6 minus 1 plus 2. Is it 0 or not? That's what we have to check. Okay, you do not need to show every details. You can use your calculator. Okay, replace every x of this function by all these rational 0 one by one. Okay, and the number that give output equals to 0 is our real 0. So when we replace x by 1, do we get 0? So this is 3 minus 6, minus 3 minus 1, minus 4 plus 2 minus 2. So 1 is not a real 0. Now let's try negative 1. Okay, you replace every x by negative 1. So if you replace x by negative 1, we get negative 3 here, we get negative 6 here, which is negative 9. This is positive 1, positive 2. So that's negative 6. So negative 1 is not a real 0. Now before fraction, let me take positive 2. Okay, so fraction is not easy, so let me take 2. So let's replace every x by positive 2. So 3 times 2 cube. So 2 cube is 8. 8 times 3 is 24, right? So let me write down that. Negative 2 square is 4. 4 times negative 6 is negative 24. Now minus 2 plus 2. This is 0, right? It means 2 is a real 0. So we have 2 as a real 0. So we know 2 is a real 0 for this polynomial function. Okay, so we know at least one. So real 0 is 2. Our target is to find every real zeros. Okay, so this polynomial has a degree 3. So this polynomial will have at least 3 real zeros. It's going to be 3 or less than 3. Now how do we find the remaining real 0? You can repeat the same process, or you can go back to this example. See, so here we had one real 0. So we had one real 0. Then after that we find a factor, right? We divided the polynomial by the factor, we factorize, and once we factorize, we had real 0, these 3. Okay, now we will use the same process here. So since 2 is a real 0, can you tell me a corresponding factor? What will be a factor? x minus real 0. So x minus 2 is a factor. Now let's divide this polynomial by this factor. What method do you want to use? I think the synthetic division would be easy and it's going to be very quick as well. Okay, so let's write down every coefficient. So x cube has a coefficient 3, x square has a coefficient -6, x has a coefficient -1, constant is 2, and we are dividing by what? We are dividing by the real 0, which is 2. So you draw first coefficient 3. 3 times 2 6. So this is 0. 0 times 2 is 0. -1. -1 times 2 is -2. 0. So this is our remainder r of x. So p of x is, divisor is x minus 2 time quotient. Now can you tell me what is the quotient here? How do we write down this as a quotient? So degree is 3. So this is x square, this is x, this is a constant. So we have 3x square minus 1. So we have our p of x in a complete factor. Now for what x value? This number is 0, 2, right? So that is a real 0. Now for what x value? This expression is 0. How do we find? You write down that factor x square minus 1, set it equals to 0, find the value of x. You add 1, 3x square equals to 1, divide by 3, x equals to 1 over 3. So x equals to positive negative 1 over root 3. So our remaining 0 are positive 1 over root 3, negative 1 over root 3. So these are the real 0 for this polynomial.